Okay, everybody. This looks a little different today. My stylus died, so we're going to try this until I can get some new batteries in. But we are going to start Unit 2, which is logs, which I believe for most of you is completely brand new. In dealing with this, I think what I'm going to do is split this up into two videos because it is a lot. So we're going to talk about the basics, and then we'll split it up into actually applying those. All right, so to start with, this is what a log is. And those of y'all with chemistry, you've at least hit this button in your calculator, but I think that's about it. So this is how you would write a log. It stands for logarithm. B is your base, and it is written down below the line. If you're on notebook paper, this would be like a subscript. And then Y would be on the line of your notebook paper, equals X. So a common log is what you put in your calculator. And a common log has log base 10. And since it's a common log and we all just accept that that's what it is, we don't write that 10 every time. So if you see just a log by itself and nothing written down here, you can assume that it's 10. A natural log goes with E. Remember last chapter we were talking about E when we were writing some kinds of exponential equations. So log base E is a natural log. So why it's not NL, I don't know, but it's a natural log, and you can just shortcut that as ln, and ln means log base E. Now these aren't new, but I did want to remind you of them because we're going to use them. So if I have the square root of something, that's the same thing as being raised to the 1/2 power. And if I have the cube root of something, that's the same as being raised to the 1/3 power. All right, so just remembering that a fractional exponent, if it's a 1/2 as a fraction, it means square root. If it's 1/3 as a fraction, it means cube root. All right, so we're going to dig into some logs here. Logs and exponential equations go the same. They're just different ways of writing the exact same information. And the shortcut, the way I always write it, is the base stays the same. And the other two numbers change places. All right, so let me show you what I mean. All right, so the first one, convert each logarithmic function to an exponential function. All right, so we know what exponential is. That was the last unit. So if your answer doesn't have an exponent in it, you did it wrong. And that sounds kind of like, well, duh, Miss G, but you'd be surprised. All right, so for letter A, your base is 2. The base is the number that's written next to the G in your subscript. So my base is still going to be my base. Now the other two numbers are going to change places. So the 3 is going to come over here with the 2, and the 8 is going to go on the other side of the equal sign. Oops, sorry, y'all. Now if you stop and look at that, that makes sense. 2 to the 3rd power is 8. So a log is actually finding the exponent. So the way you would read this, if you're thinking in your head, you're going, okay, 2 to what power, 2 to what exponent gives me 8 as my answer? And it's 2 to the 3rd power gives you 8. So a log is finding that exponent, figuring out what exponent takes your base and turns it into your other answer. All right, so letter B. This one doesn't have a base written down here, and so we can assume it's a common log up here. So that means it's base 10. All right, so our base stays the same. The other two numbers change places. So the 5 is going to become the exponent, and the 100,000 goes after the equal sign. And again, stop and think. Does that make sense? Yeah, 10 to the 5th power is 100,000. That works. That makes sense. Okay, over here for letter C. Base is 2. Other two numbers trade places. So it's going to be 2 to the 3rd power equals 1/8. And that does make sense. Remember, a negative exponent means you're going to take it and you're going to flip it. You're going to move it. So that 2 to the third power would go to the bottom of the fraction, and 2 to the third power is 8. So that works. Last one over here, your base stays the same, so it's 5, and the other two things change places. So r is going to become my exponent, s goes after the equal sign. Now, we don't know for sure if that's the correct answer because both of those are variables, but we've written it correctly. We don't know what those letters stand for. All right, so example 2 is taking it the other direction. And if you look, it is the exact same problems, but it's just working them through the other direction. So for this one, it says convert each exponential function to a logarithmic function. So again, your answer must have a log in it. If it's asking you to write a logarithmic function, it has to have a log. If you don't have a log, it's wrong. And again, just like I said with example 1, duh, that makes sense. I'm like, yes, but having graded a bunch of quizzes on these before in my time, people tend to get confused on what it's asking for. So if it's asking you to write it as an exponential function, your answer has to have an exponent. If it's asking you to write it as a logarithmic function, your answer has to have a log in it. All right, so it has to have a log. All right, our base is 10, so you can write it there, and then the other two numbers change places. So 100,000 equals 5. Now, since that's base 10, it's a common log. So if you want, you can leave it as log base 10. That's fine. Or you can write it like this. Both of those answers are correct. It doesn't matter which way you do it. All right, for letter B. So we know it has to have a log. The base is 2, and the other two numbers change places. So it becomes log base 2 of 8 equals 3. All right, for letter C, we know it has to have a log. The base is 5, and then the r and the s change places. So log base 5 of s equals r. And the last one, letter D. So we know it has to have a log. The base is 2, and the other numbers change places. Log base 2 of 1/8 equals -3. All right, so that's the basics on what a log is. So if you're finding a logarithmic function, what you're doing is you're finding the exponent of the base that gives you the other answer. A lot of times logs are going to work out to be ugly, kind of negative. Not negative. They're going to end up being ugly numbers with lots of decimals. That's okay. That's where the calculator comes in handy. But for right now, just looking at the beginning ones, that's what you need to know. All right, so second part is evaluate. So if you see the word evaluate, that means get a number answer. All right, so the way I do these is I write them as exponents because for me, it's much easier to see what I'm solving for if I write it in exponential form. All right, so for the first one, our log in letter A doesn't have a base, so that should be log base 10. All right, so we have our 10. The other two things are gonna change places. So 10 to the power of x equals 1,000. And so the question that I have for you guys right now is, okay, what exponent of 10 gives you 1,000? So 10 to what power gives you 1,000? Well, 10 times 10, which is 2. 10 times 10 gives us 100. 100 times 10, which would be to the third power, gives us 1,000. So in this case, x equals 3. So log base 10 of 1,000 is 3 because 10 to the third power gives us 1,000. All right, over here for letter B. So it'll be 2 to the x equals 32. All right, and again, got to go through and figure out our exponents. So 2 times 2 is 4, so that's 2. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So x to the 5th power gives us 32. So 2 to the 5th gives us 32. All right, over here for letter C, it's base 16. The other two numbers change places. All right, so let's stop for a second. It's 16 to what power gives us 4? So it's getting smaller. So if it's getting smaller, that means we're using a fractional exponent. So we talked about square roots and cube roots. So the square root of 16 gives us 4. So x would have to be 1/2, because 1/2 is the fraction that goes with square roots. If it was a cube root, then we'd have to write it as 1/3. All right, and the last one would be 5 to the power of x equals 125. All right, so 5 times 5 is 25. 25 times 5 gives us 125. So it's x to the 3rd power. All right, so if it says rewrite or convert, you just put it in whichever form it asks for. If it asks you to evaluate, that means you need to get a number answer. Okay, so these are the basic properties of logs. The nice thing is these are pretty straightforward and they're relatively easy to remember. So this one would be log base a of 1 equals 0. So in words, that's here. But if I were to write it in symbols, it means anything to the 0 power equals 1. That's how you would rewrite that. And that's true. So anytime your number right here is a 1, your answer is automatically 0. All right, for number 2, it's log base a of a equals 1. So if you were to write that in exponential form, this is what it looks like. So anytime you get a log where the base and the number you're finding are the same, your answer is 1. All right, for number 3, it looks pretty similar. So what that one is saying is a to the x equals a to the x, and that's true. So if you have a base and your number that are the same, and that number has an exponent, that's what your answer is going to be. All right, and then for number 4, take a look at this. The base of the exponent and the base of the log are the same. When you see that, basically you can cancel them out, and your answer is whatever the log is finding a number of. All right, so let's actually see what this looks like when it's actual problems here. All right, so this is log base 5 of 1. All right, that's like this first rule. So anytime this number right here is 1, your answer is automatically 0. You don't have to do anything. It's the only way you're getting 1 as your answer is if you are raising it to the 0 power. All right, for letter B, it's log base 5 of 5. Well, those are the same thing. So that's step 2. So your answer has to be 1, because the only way you're getting those to be the same thing is if you're raising 5 to the 1st power. All right, when you look at C, we've got log base 5 of 5 to the 8th power. Well, that's just like 3. Your base and the number that you're finding the log of are the same, so you can cancel those out and you're left with whatever that exponent is, so 8. And then for letter D, it's just like number 4 right here. The base of the exponent and the base of the log are the same. When that's true, those cancel out and you're left with whatever your answer was. So when they're written like this, it's pretty easy. If you recognize the patterns, there's not much work. It's just canceling things out. All right, so for letter E, log base 5 of 5 to the 4th power, those cancel and you're left with 4. For this one, log base 4 of 64. Okay, so that one doesn't match any of our rules that we talked about. So let's write it as an exponent. All right, so this is saying, okay, 4 to what power gives us 64? Well, 4 times 4 is 16. 16 times 4 is 64. So our answer is 3. All right, letter G does match one of our rules up here. It's log base 9 of 9. Those are the same. So our answer is 1. All right, letter H does not match our rules. So let's write it as an exponent. 8 to the power of x equals 64. All right, so 8 times 8 gives us 64. So that's 2. 8 squared is 64. All right, for I, same setup. Log base 7 of 49. doesn't match our rules, so we can write it as an exponent. So 7 squared gives us 49. All right, J does match one of our rules. It's log base 7 of 7 to the 10th power. So the bases are the same, so those cancel, and we're just left with 10. All right, for K, they don't match, so let's write it as an exponent. So 3 to the x equals 1 over 27. All right, this side is not a fraction, and this one is. That should give you a warning sign that you should have a negative exponent in there somewhere. All right, and then 3 to the 3rd power gives us 27. So that would actually be negative 3. 3 to the negative 3rd power gives you 1 over 27. The negative flips it over, and then 3 to the 3rd power gives us 27. All right, letter L doesn't look like one of our rules, but it actually is. So let's rewrite it for a second. Remember we said square roots mean to the 1/2 power. So here, log base 10 of 10 now matches number 3. So those cancel, and you're just left with 1/2. All right, so we're simplifying these logs down. We were evaluating, we were reducing, we got number answers for all of them. These 4 rules plus how to write it as an exponent are how you're going to want to solve these. So make sure that you're taking a look at those and keeping up with them. All right, then natural log. So natural log, just like the common log was log base 10, your natural log is log base e. Good news is all of these rules are exactly the same as the ones we just looked at for logs. They just have an ln instead of log. It's the exact same thing. All right, so ln of e to the 8th power, that's the same as log base e. So if you think about it like that, all right, that's just like the one we had before. We can cancel that out, and it's 8. All right, this one, so it's written as a fraction, so we need to think about that a little bit. So I would rewrite that as natural log of e to the negative 2. All right, once we're there, that's just like number 3. Those can cancel out, and we get negative 2. Natural log of e, that's just like number 2 right here. So natural log of e is 1. Natural log of 1 is just like up here, it's 0. So a reminder, if it's natural log, that's log base e. So this is saying log base e of 1. And the only way you're getting 1 as your answer is if you raise it to the 0 power. All right, over here for natural, or e raised to the natural log of x, those are going to cancel out, and you're going to be left with x, because that's the same as this. All right, and then those cancel. Over here, this is just like letter A. Natural log of e to the 4th power is 4. And for F, let's rewrite that. So it's natural log of e to the negative 1. Then it's just like A again. Those cancel, and you're left with negative 1. All right, so we're going to stop there on this video. Take a second, digest what you've done, look back over that, make sure you feel comfortable with it, and then when you're ready to pick back up, we'll start with part 2.